Good morning, and once again, welcome to my YouTube channel, Maths with Ease. And in this video, I want to respond to a question in example 2 of slide number 6 in topic number 19 of Form 1 Mathematics. And we are being told that solve the simultaneous equations below graphically. And what are they? 3y minus x minus 4 is equals to 0. And 2x minus 5y is equals to minus 7. And we are told that x should take the values of from minus 2 to positive 2. And as usual, what we need to do is we need to come up with tables of values for each and every graph. And we have, for example, this equation 1 and this is equation 2. We need to rewrite equation 1 as 3 minus x is equals to positive 4. And we have the corresponding table of values here, all the way from minus 2, minus 1, 0, 1, and 2. And we will calculate the corresponding values of y. That is equation 1. And equation 2, we need to have it here, and we have 2x minus 5y is equals to minus 7. And then we have x and y, again using the same values, minus 2, minus 1, 0, 1, and 2. We have to have the corresponding values of y again within that range. And we start with the first one. When x is negative 2, 3y is equals to minus negative 2, which is plus 2. So 3y plus 2 is equals to 4. 3y plus 2 is equals to 4. So 3y is equals to 4 minus 2, which is, let's have it here. 3y minus 2, that means plus 2 is equals to 4. So 3y is equals to 4 minus 2, which is 2. And y is equals to 2/3. So we have 2/3 there. Go for the second value of x when x is negative 1. So 3y minus 1, we are going to have 3y plus 1 is equals to 4. So 3y plus 1 is equals to 4. We have 3y plus 1 is equals to 4. So if we take 1 across, then we're going to have 3y is equals to 3. And y is 1, having divided both sides by 3. So that is 1. When x is 0, then 3y is equals to 4. And y is 4 over 3. 4 over 3. When x is 1, so 3y minus 1 is equals to 4. So 3y is equals to 4 plus 1, which is 5. 5 divided by 3 is 5 over 3. When x is 2, then we have 3y minus 2 is equals to 4. So 3y is 4 plus 2, which is 6. So y is 6 divided by 3, which is 2. And we can easily use these 2 points, that one and that one, because we will get very accurate values. Let's go to the next question. And when x is minus 2, minus 2 times minus 2 is minus 4, minus 5y is equals to minus 7. So easily we can always bring negative 5y across, and you're going to have minus 4 plus 7 is 5y. And this one is going to give us something to do with minus 4 plus 7 is actually 3, and y is 3 out of 5. So we have 3 over 5. When x is minus 1, we can have minus 2 plus 7 is equals to 5y. Minus 2 plus 7 is equals to 5y. That is by bringing 7 across and minus 5y to the other side, they both change the sign. So this one is just 5 is equals to 5y, and it gives us y, this gives us y is equals to 1. So when x is negative 1, then y is positive 1. And we only need 2 points that are very, very conspicuous. Let's try when x is 2. When x is 2, then we have 4 plus 7. 4 plus 7. 2 times 2 is 4. 4 plus 7, which is 11, is equals to 5y. And we are talking of 5y is equals to 11. And y is equals to 11 out of 5, 2 and a fifth. What would happen when x is a 1? So let's talk of when x is a 1. Let's see what happens when x is a 1. So 1 times 2 is 2, plus 7 is equals to 5y, and y is equals to 9 out of 5. So when x is a 2, we have seen that y is 11 over 5, 11 over 5. When x is a 1, 9 over 5. And when x is a 0, then we can already tell that 5y is equals to 7, so 7 out of 5. What we need to do now is to construct now the graph. Constructing the graph requires us to talk of what? To talk of this. Let's have the x and y axis. That is the y axis. And this is the x axis. This is the x axis for that matter. So we are having, this is now our x axis. So when x is, let's say, minus 1 and up to here minus 2, x is a 1, x is a 2, then we say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. And we have something like this now. And we're consulting the table for this graph. When x is minus 1, y is 1. When x is minus 1, y is 1 for this equation. And this is the point. When x is 2, y is 2. And that is, we have now to join the 2 points and produce the line, because we never know where the 2 lines are going to intersect. We have to draw that line and produce that line and call it 3y minus x minus 4 is equals to 0. That is the name of that line. Come to the other one. When x is negative 1. When x is negative 1, y is again 1, the same point, that one. When x is a 0, y is 7 over 2, which is 1.4. 1.4 somewhere. When x is a 2, let's have this. This is going to be 11 over 5, which is 2 point something, 2 point 11 over 4 is 2 point, let's have 11 divided by 5 is 2.2. When x is 2, then 2.12, somewhere there, very close. And we have to join it with this particular point. And you have to be very careful because the graph has to be very accurate. Join the 2 points and let them be very, very distinguished. So 2.2 and this point, so you come up with a graph that looks like that. Now, this one may not be very clear example on how to solve the simultaneous equations graphically, but of course, you can see the 2 the 2 lines meet here. So the point of intersection are the solutions of the 2 simultaneous equations, and x is -1 and y is equals to +1. These are the solutions to the 2 simultaneous equations. I will come up with another one which we are going to have very distinguished lines, which are not going to be very close to each other. But either way, what we are trying to say here is that when you draw 2 linear graphs in the same set of axes, then the solutions of the 2 simultaneous equations are the coordinates of the point of intersection. In this particular case, the 2 lines intersect at the point -1, 1, giving us x is equals to -1 and y is equals to +1. Thank you, and let us stay awake and alert for other videos.